Hello everyone! Welcome to our learning activity video, and this is your teacher Manichu, and we are in Mathbox grade 9. So we are to discuss the problems involving quadratic equations and rational algebraic equations. So let's start with the problems. Moving on to the exercises, we have for the directions, solve the following problems and write your solution in your activity notebook or answer sheet. For problem number 1, the product of two consecutive integers is 210. Find the integers. Solution: let x be the first consecutive integer. And of course, x plus 1 be the second consecutive integer. Now we have here the mathematical statement: x times x plus 1 equals 210, because it says in the problem that the product of two consecutive integers is 210. So this is the mathematical statement. Moving on, we have here distributing x to quantity x plus 1. We have x squared plus x. Then transposing the constant 210 to the other side, we have negative 210. Leaving the right hand side equals 0. Then factoring out these quadratic equations, we have x plus 15 times quantity x minus 14 equals 0. Then we have two linear factors and set each of the linear factor to 0. In this case, x plus 15 equals 0, giving us x equals negative 15. On the other hand, x minus 14 equals 0 will give us x equals 14. Checking, if we take x equals negative 15, then the next consecutive number or integer to negative 15 is negative 15 plus 1, and that's negative 14. Now, is the product of negative 15 and negative 14 210? It's true. So we have a true statement. Now let's take x equals 14. Verifying x equals 14 in the mathematical statement, we have 14 if x, then the next to 14 is 15. So 14 times 15 is 210. Again, it's a true statement. So we have here the conclusion that there are two sets of solutions that we have in this particular problem. Anyway, we are asked to find the two integers. So, solution set number 1 would be x equals negative 15 and the other one is negative 14. And it will give us a product of 210. The other one is if x is 14, the next one is 15. So, this is the solution for the number 1 problem. Number 2, the sum of a number and its square is 156. We are to find the numbers. So we let x be the number, and it says the sum of its square. So x plus x squared equals 156. Then we have a quadratic equation here. We transpose the constant on this side, so leaving the right hand side 0. So x squared plus x minus 156. The factors: x plus 13 times x minus 12 equals 0. So we have values of x equals negative 13 or x equals 12. Checking, let's consider x equals negative 13. Now negative 13 plus the square of negative 13 is 169. Is it equal to 156? Yes, it's true here. 169 minus 13 equals 156. What about if x is 12? Then 12 plus the square of 12, which is 144, is 156. It's a true statement. Hence, the numbers are x equals negative 13 and x equals 12. So there are two solutions for the values of x. For number 3, a room contains 112 chairs. The number of chairs per row is 5 less than 3 times the number of rows. find the number of chairs per row. Now, at the very first time you read this problem, you might find it hard to formulate a mathematical sentence. But in this case, I'll give you a tip. One tip is, what would be the x? Is it the number of chairs or the number of rows? The tip is, you try to read the problems over and over again until you internalize the problem. And try to find out what is less described in the problem. In this case, there are two quantities that we are supposed to let x be. Let's say the number of chairs per row and the number of rows, which is our x. The x is the one that is less described. So in this case, the number of chairs per row is 5 less than 3 times the number of rows. Take note, the number of chairs per row is described. So meaning the number of rows is not described. Or in Tagalog, we can have it as kulang sa pansin. So the number of rows is kulang sa pansin because it is less described in the problem. So when that is the case, then let x be the number of rows, so that the number of chairs per row will be in terms of x. It says that the number of chairs per row is 5 less than 3 times the number of rows. Whatever is that, in this case it's x, is the number of rows. So we have 3 times x less that by 5 is the number of chairs per row. And how to get this mathematical statement? X times quantity 3x minus 5 equals 112. We know for a fact that if given a rows, the number of rows, x rows, and we have per row, we have 3x minus 5, then the product of that will give us the 112 chairs. So that is our mathematical statement. Then, distributing x to quantity 3x minus 5, we have 3x squared minus 5x. Then, transpose this to the other side, that becomes minus 112 equals 0. Here, we are not sure. We can factor this by trial and error. Of course, we can set up the two open parentheses, closed, and another factor, open parentheses, and then closed parentheses. Then we consider 3x squared. What are the factors of 3x squared? Since 3 is a prime number, so we can say 3x and 1x, or simply x. And then, what are the factors of negative 112 in such a way that the middle term will give us negative 5x. In this case, before I laid this down here, I wrote it down, I consider first the use of quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the discriminant. In this case, I found out that 16 and 7. So I resorted to factoring technique. Factoring is the most efficient way of solving a quadratic equation. So in this case, as long as you know the factors. So the factors of 112 are 16 and 7. Take note, the negative sign here will indicate that the signs of 16 and 7 are different. Okay, let's try to consider this. 3x plus 16 times x minus 7 equals 0. Now let's try to check first. 3x squared, then we have the middle term 3x times negative 7, that's 21, negative 21x plus 16x, so this will give us negative 5x, so it's done. Then we have negative 16 times negative 7, that's negative 112. So these two factors are true factors of this given quadratic equation. So we are now on the linear factors. We started with a quadratic expression or equation. Then, by factoring, we break it down into two binomial linear factors. So, each of these will be equated to 0 to look or to find the value of x. So, in this case, x is negative 16 thirds or x equals 7. We have to take x equals 7. Why? Because we are considering x to be the number of rows of chairs. So it should be positive. Taking negative 16 over 3 is not relevant and immaterial in this case. Now checking x equals 7, we have to substitute to this mathematical sentence or quadratic equation. So 7 times quantity 3 times 7 minus 5. This 3 times 7 minus 5, we have 21 minus 5, that is 16. So in this case, at this part, we wrote here a question mark, signifying that we are not yet sure. We are verifying whether this is a true statement. So at this point, it is not verified yet, or it is not validated that it's equal to 112. So we put a question mark. But in this case, we have here 7 times 16. It's true that it's 112. So therefore, there are 16 chairs in each row. Why? We have 7 rows. So 3 times 7, that's 21 minus 5, it's 16. So we answered what is asked in the problem. For number 4, find 2 consecutive odd integers whose product is 99. For the solution, let x be the first odd integer and x plus 2 be the second odd integer. Why x plus 2? Because it says here 2 consecutive odd integers. So example of odd integers 1, 3, 5, and so on. So if x is 1, then the next odd integer is 3. So what is added to 1 to make it 3? It's 2. Then what is added to 3 to make it 5? 2. So meaning whatever is that first odd integer, then we add plus 2. So we have the second odd integer. Now it says that 2 consecutive odd integers whose product is 99. So we have to find those 2 consecutive odd integers. So it's simple as multiplying x times quantity x plus 2 equals 99. And distributing this, x squared plus 2x, then minus 99 equals 0. Then solving for x, but we have to factor this out. We have here x squared, so x and x. Then we have negative 99. So what are the factors of negative 99? So we can have here 11. So we have x plus 11, then x minus 9. So 11 minus 9 will give us positive 2 in the middle, coefficient positive 2. So we set this equal to 0 and we have linear factors, and eventually we have x equals negative 11 or x equals 9. For checking, let's take x equals 11. For the checking, we verify negative 11, then negative 11 plus 2, is this equal to 99? Well, negative 11 plus 2, it's negative 9. So times negative 11, it's 99. It's true. Let's take x equals 9. So x times x plus 2 equals 99. Then x is 9. Then 9 plus 2 is 11. 9 times 11 is 99. It's a true statement. So we can say that the 2 consecutive odd integers are 9 and 11, or we can have negative 11 and negative 9. For number 5, find 2 consecutive positive integers such that the square of the first decreased by 17 equals 4 times the second. So read the problem over and over until you internalize. But what is asked is we have 2 consecutive positive integers. So in this case, let x be the first consecutive positive integer, and of course, let x plus 1 be the second consecutive positive integer. It says here that such that the square of the first decreased by 17. So we have here x squared minus 17 equals, we have 4 times the second, so meaning 4 times the quantity x plus 1. So simplifying this, we have x squared minus 17. We distribute 4x, so 4x plus 4. Then we have x squared minus 17. Then transposing to the left-hand side, negative 4x, negative 4, leaving the right-hand side 0. So simplifying further, we have x squared minus 4x minus 21 equals 0. Then we have x squared here, so we expect it on this part x and x. We're not sure, so we are to factor by trial and error. What are the factors of 21 such that the difference would be -4? So in this case, -21. So we have x minus 7 times x plus 3 equals 0. Let's try to check first. We have here, let's try to multiply these two factors, x squared. Then we have 3x minus 7x will give us -4x. Then -7 times 3, we have -21. It's correct. So, following these steps, we ended up with x equals 7 or x equals -3. Since we are asked to find positive integers, so we take x equals 7. Of course, what follows 7 is 8, right? So let's check. X equals 7. Then we have x squared is 49 minus 17. Is this equal to 4 times 7 plus 1 or 4 times 8? We have a question mark. So 49 minus 17 is 32. Then 4 times 8 is 32. So we have a true statement. So what are those two consecutive positive integers? Well, we have here 7 and 8. This solves our problem in number 5. We move on to number 6. The ages of 3 family children can be expressed as consecutive integers. The square of the age of the youngest child is 4, more than 8 times the age of the oldest child. Find the ages of the 3 children. Solution. What is or what will be our x? Well, let x be the age of the youngest child. It says here, the ages of 3 family children can be expressed as consecutive integers. So we have x plus 1 be the age of the middle child, and of course x plus 2 be the age of the oldest child. Okay? Then it says again the square of the age of the youngest child, that is, youngest is x, so x squared is 4, more than 8 times the age of the oldest child. So the is there is an indication of an equality symbol. So is. Then 4, you add it later, 4 more than. Then 8 times the age of the oldest child. So what is the age of the oldest child in terms of x? As we had defined here, it's x plus 2. It says 8 times. So we have here 8 times the quantity x plus 2. Then 4 more. Then we have plus 4. So this is our mathematical statement or our equation. This is the most challenging part of the problem. Once this is established, then we can proceed to solving for quadratic equations. It's easy to solve once this is established. So the problem is understanding the problem and internalizing it so that you can formulate the equation. So moving on, we have x squared, then we distribute 8 to quantity x plus 2, so we have 8x plus 16, then we have plus 4, giving us x squared equals 8x plus 20. Then collecting all terms on the left hand side, we have x squared minus 8x minus 20 equals 0. Then again, we have x squared here, so we expect we have x here on this side of the factor, and then this one equals 0. We're not sure of the other terms in the two binomial factors, but we are sure that the product must be -20, and sum of the factors would be -8. So in this case, let's try x minus 10 and x plus 2 equated to 0. Let's check first. X squared, then 2x minus 10x will give us 8x. Then -10 times 2 will give us -20. So this is the correct factor. Equated to 0, and finally, x equals 10 or x equals -2. We take x equals 10 because there is such no negative ages. So we have 10 as the age of the youngest child. Then we check it is x squared equals a times quantity, x plus 2 plus 4, so x squared is 100. Then we have 8 times, this is 10 plus 2, 12 plus 4. Then 100 is equal to 96 plus 4, which is a true statement. And then, of course, the youngest child is 10, the middle child is 11, and the oldest child is 12. Hence, the ages of the 3 children are 10, 11, and 12. Moving on to the numeracy scale, we have here directions. Find the equivalent fraction in lowest term of each of the following decimals. Copy and write your answers or solutions in your activity notebook or answer sheet. For number 1, we have the decimals. 0.3 equivalent fraction is 3/10 or 3/10. For number 2, it's 0.8, then it is 8/10 or 4/5. Number 3, 0.5, we have 5/10, and that is equal to 1/2. 3.2, we have 32/10 or 3 2/10. That is equal to, the simplified form is 3 1/5. And 0.41, we have 41/100. So this ends our learning activity review. Please don't forget to like this video, and if you have any comment, kindly comment down below. And for those who were not able to subscribe yet, please click on the button, the subscribe button. And again, this is Teacher Marichu saying always stay happy, healthy, and safe. God bless.